Here we have the 2002 AP Physics B free response questions, Form B. So, first, two parallel conducting plates, each of area 0.3 meters squared, are separated by a distance of 2.0 times 10 to the negative 2 meters of air. One plate has charge positive Q, the other has negative Q. An electric field of 5,000 newtons per coulomb is directed to the left in the space between the plates, shown in the diagram above. So part A is asking, indicate on the diagram which plate is positive and which is negative. The answer for that is right over here. The left is negative and the right is positive. That's true because you go out of positive into negative. So part B. That's asking, determine the potential difference between the plates. So potential difference for plates is E equals V over D. And we want to find V. So we're going to manipulate the formula to be V equals E times D. So you get 5,000 newtons per coulomb times 2.0 times 10 to the negative 2 meter. And you get an answer of 100 volts equals V. Part C is asking, determine the capacitance of this arrangement of plates. See, so because it's plates and we have an area of 0.3 meters squared, we're going to do C equals, I don't know how to say that, epsilon times area over D. And epsilon is equal to 8.85 times 10 to the negative 12 coulomb squared per Newton per times meter. We're going to multiply that by the area all over the distance, and our capacitance is 1.3 times 10 to the negative 10 force. Part D wants to, if an electron is initially located at a point midway between the plates, determine the magnitude of the electrostatic force on the electron at this location and state its direction. So D, we want the magnitude. So we're going to do F equals QE. So we're going to have an electron has a charge of 1.6 times 10 to the negative 19th coulombs, and our electric field is 5,000 newtons per coulomb. And that will equal 8.0 times 10 to the negative 16th newtons. It'll go to the right because an electron will go to positive because this is positive, so it's attracted there. Part E is asking, if the electron is released from the rest at this location midway between the plates, determine its speed just before striking one of the plates. Assume that gravitational effects are negligible. So we're going to have work is equal to QV, which is also equal to half mv squared. When you manipulate that, you get V is equal to the square root of 2 QV over M. And when you plug into that, you get 1.6 times 10 to the negative 19th coulombs times 50 volts. The reason it's 50 volts is because we're going from the center of the plate to only one, center of the electric field to only one plate, it's going to be half of the electric potential of both plates. And then you divide that by the mass, which is 9.11 times 10 to the negative 31st kilograms, all over a square root. And that'll be equal to 4.2 times 10 to the 6th meters per second. And that's it for this video, guys.